Hi everyone, today we will be going through a couple of examples, where we will be applying the chain rule to find the derivative of given functions. Let's have a look at the chain rule that enable us to differentiate a function of a function. The chain rule states that, if t is differentiable at x and f is differentiable at g function, then the composite functions f and g are differentiable at x and f is given by the product. There will also be situations where we will have to use the power rule combined with the chain rule. We also have a formula to remember when dealing with non-constant exponents. Now let's flex our muscles by going through a couple of examples. Starting with a 1 minus x cubed to the power 10. We first add the derivative notations. It's a function of a function, therefore, we need to apply the chain rule. When applying the chain rule, we need to multiply the entire function by 10. And then, subtract this 10 by 1. And then we need to multiply the entire function by the derivative of the inner function. This will then give us 10 times 1 minus x cubed all to the power 9 times the derivative of the inner function. Then we just simplify until we get the final answer of 30x squared times 1 minus x cubed to the power 9. Then, we simplify even further. Now let's do b sin natural log with the power x. We first add the derivative notations. Here again, we need to apply the chain rule. Because this trig function is a function of a function, when applying the chain rule, we multiply derivative of the outer function with the derivative of the inner function, and get our final answer of cos natural log power x times natural log to the power x. Now let's do c 4a to 4 minus 3x plus x cubed. We first add the derivative notations. Here, we need to apply the chain rule because this one is also a function of a function. We then differentiate summand separately and pull out constant factors. Then simplify to get our final answer of 3x squared minus 3 over 4 times square root of x cubed minus 3x plus 4. Now let's do d cube root of 1 plus tan t. We first add the derivative notations. Again, it's a function of a function, we apply the chain rule. We then differentiate summand separately, then simplify until we get sec squared t over 3 times 2/3 root of tan t plus 1. Let's try this one, e. Inside bracket 2x minus 5 all to the power 4 times 8x squared minus 5 all to the power minus 3. We start by adding the derivative notations. We turn it into a quotient and apply the quotient rule. We then differentiate summand separately and pull out constant factors. Then, we simplify throughout until we get simplified final answer of 8 times 2x minus cube over 8x squared minus 5 all to cube minus 48x times 2x minus 5 all to power 4 over 8x squared minus 5 all to power 4. Now let's try this one, f constant to cube plus cos cube x. We start by adding the derivative notations. We then differentiate summand separately. Apply the constant rule on the constant on the left. We then apply the chain rule on cosecant cube x on the right. Then, simplify to get the final answer of minus 3 sin x cos squared x. Now, give these ones a try. I hope you found this tutorial helpful. Feel free to click on the like and subscribe buttons below.